Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 45 from the Smith Organic Chemistry textbook. This problem asks us to draw the product formed when phenylacetaldehyde is treated with each reagent. And then we're told a little bit about phenylacetaldehyde. But so at the top of the screen here, I've drawn phenylacetaldehyde, and I've also indicated that for all these answers, rather than redrawing the phenyl ring each time, I'm just going to use pH as an abbreviation. That should hopefully save some time. And I'll do my answers in green just so that they stand out a little bit. So sodium borohydride is going to reduce the aldehyde to an alcohol. So our product is going to be this. Okay, for B, lithium aluminum hydride followed by water is going to do the exact same thing. So we're also going to reduce the aldehyde to an alcohol here. Okay, so our products for A and B are the same. For C, we are using a Grignard reagent. And so we will add a methyl group and reduce our aldehyde to an alcohol. So we've added a methyl group and we have an alcohol as the residue of our aldehyde. Okay, so then for D, we are using sodium cyanide and HCl. And so in this case, cyanide is our nucleophile. So we end up with a nitrile and an alcohol. And so that is our product. For E, this is a Wittig reagent, so we're going to do a Wittig reaction. And so we end up adding what's attached to the Wittig reagent. And so basically, so 1, 2. So we have a new double bond that's formed here. And then we add the 2 carbons that are on our Wittig reagent. So 1, 2, 3, 4. So this is going to be our product right here. And remember, we would get E and Z isomers. So we can just indicate that we would get both E and Z. Okay, so for F, we're using a primary amine and some acid. So this is going to be an imine that we form. And so our imine product is going to look like this. So we'll still have a hydrogen here. We have a nitrogen here now, and we've added what is attached to the imine, which in this case is an isopropyl group. And so our product is going to be that right there. Okay, moving on to the next page. So for G, we're using a secondary amine. So our product is going to be an enamine rather than an imine. Oops. I always forget when I change pages, I have to reselect my color. So there we go. So our product for G, as I said, is going to be an enamine. And so that is going to look like this. So we have a double bond here and our nitrogen with the alkyl groups that are on it. Okay, and once again, we'll get E. Oops. Once again, we'll get E and Z isomers. So E and Z. Okay, for H, we're using excess methanol and some acid. And so we're going to form the acetal here. And so that is going to look like this. So there is our acetal that we form. For I, this is going to be another enamine that we form. You might not realize it upon first look, but that is a secondary amine that we're using. And so there's really no difference between I and G other than the alkyl groups that are on the nitrogen. And so our products are going to look very much the same. And once again, we'll get E and Z isomers here. Okay. And lastly, for J, we're going to form a cyclic acetal here using ethylene glycol. And so that is going to look like this. So there we go. There's our cyclic acetal. Okay, there's no secret to this problem. You just need to know what every single one of these reagents does when used on an aldehyde. And they were all covered in this chapter. So we have reductions, we have Grignard reagents, cyanide nucleophile, a Wittig reagent, formation of an imine, formation of a couple enamines, and then formation of acetals. And that's the answer to chapter 21, problem number 45.